Continuing our study of exponential equations, we're now going to solve an exponential equation that has different bases. So you cannot directly equate the powers because you have a 2 on the left side as a base and you have a 4 on the other side. However, what you can do is you can transform it so that you have the same base on both sides. And if you notice that we have a 4, which can be written as 2 squared, this is what we're going to do. So we have 2 to the power x minus 3 equal, instead of 4, we're going to write it as 2 squared, okay? And that's raised to the power x minus 5. Now here we are going to use properties of powers. So if you raise an expression to a power and then raise that to another power, the rule says that you're going to be multiplying the powers. So this is going to become 2 to the power x minus 3 equal 2 to the power. Now, you're going to be multiplying that power right here. So this power right here, you're going to be multiplying that by x minus 5. Now, when you do that, you have to distribute that 2 to both terms. So that's very important. So this is going to be 2 times x, which is 2x, subtract 2 times 5, that's 10. And now I can type that in here. So I think what I will need to do is just have 2x minus 10. Just make sure it stays on the top. Okay, so now I have the same basis on both sides, and now I can equate the powers because of the one-to-one property of exponential with the same base. So you have x minus 3. I will make that equal to 2x minus 10. All right, how do I solve that? Well, I want variables on one side and numbers on the other side. I prefer to have a positive coefficient of x, so I will subtract x from both sides. And then over here, it'll cancel. And I'm going to get negative 3 equals. Now, what is 2x subtract x? So this is 2x subtract 1x. And that's just going to be x minus 10. So I now have variables on the right side, but I want all the numbers on the left side. So I need to get rid of minus 10, which I can do by adding 10 to both sides. Okay, so that'll cancel it here. And then I will wind up with x equals negative 3 plus 10, and that's a 7. Now, what's important is, as I was telling you before, when you think the answer is, let's say, 7, you need to verify that. So open up your calculator, plug in the 7 in the original equation. Do not plug it into some intermediate step because it is possible that you messed up somewhere on the way. So let me just plug 2 to the power, and let's just put it in parentheses so it stays on the top. So 7 minus 3. Okay, so that's 16. And then I'm also going to do the same thing on the right-hand side. So plug 7 for x, and I can see that the two are the same, and that tells me that I did it right.